Cool. So from floating cities and engineering, we will take you back to facades engineering and building scale discussion. Good afternoon, everyone, and thank you for joining us on this esteemed panel that promises to have a, I would say, an insightful opinion and a forward-looking discussion with the various backgrounds of professional experts in facade, architecture, sustainability, and MEP. We will be talking about the future of facades, but from our previous discussion with the panelists off stage, everyone endorsed and wanted to highlight the importance of talking about the existing systems or the existing designs that we are dealing with in the market and the importance of setting kind of a baseline before moving forward into the future of facade and the adaptation of new technologies and the tools that we are dealing with. So we will be tackling various subjects. We will be talking about the baselines and the designs. We will be talking about the importance of integration, computational design, and the BIM, and how is those tools implemented into the facade engineering, and how is it helping and feeding into the solutions of the systems that we are trying to build on site. We will be talking about the famous triangle of sustainability, design, and cost, and how is this tackled in every and each project that we are dealing with on site. And for sure, we'll be talking about the correlation between facade engineering and MEP, the importance of the coordination between those two disciplines, and what risks rises during construction, I would say, because of the miscoordination of these two disciplines. So I will kick off the panel by asking each panelist to please introduce yourself, your company, and your work passion. Starting with you, Jason.
Work passion.
Work passion.
Okay. I'm Jason Pardesi. I look after the structures and facades groups at GHD in the UAE. My passion, my background is in complex geometry, so I've got a real passion for digital technologies and how we can use them on complex facade projects, but also a background in passive house design. So between those two, I think that's today's going to be a good talk.
Cool. Thank you. Surbhi?
Good afternoon, everyone. I'm Surbhi Saran. I am a senior building physicist with AESG. My specialty lies in simulations and to provide insights to our clients on building envelopes, microclimate, and human thermal comfort within the buildings. My background is in architecture, but I've spent about 8 years in sustainability. I'm really passionate about resource conservation, and I'm really happy to be here. Thank you.
Thank you very much, Stuart.
I'm Stuart Rennie. I'm a senior architect at Adjaye Associates, based here in Dubai. We sort of specialise within cultural projects. We do a lot of residential as well. We recently just finished the Abrahamic family house in Abu Dhabi. So we tend to focus on bespoke projects like that.
Thank you. Very interesting project. If you didn't visit yet, go, because it's a really very interesting project. Imran?
Thank you, Gina. Hi, everyone. My name is Imran Shaikh. I'm the Director of MEP and Specialisms at Ramboll, and I'm also the CPI UAE Chair. I've been in the region since childhood, and my passion is towards integrating technology into MEP design, which can bring in the holistic MEP solution. So, yeah, pleasure to be here today.
Thank you, Imran. Izzeddin, please.
Assalamu alaikum, everyone. My name is Izzeddin Hasan. I am MEP Chief Engineer from Merid. I'm working there since 1 year. Merid is a real estate developer now in Dubai, which they are doing great projects. And previously, I was working with one of the biggest company in construction, which is B6. I was there like in 14 years. And now I'm here with guys here just to try to speak about MEP interfaces with the facade.
Thank you for attending the panel. So I'll start with you, Jason, and with the idea or the importance of setting the baseline. So from our discussion, And when we wanted to set kind of the panel topic and subjects to be discussed, the panelists were very keen into discussing what do we have at the moment and what tools, codes, baselines do we have at the moment that we can re-look into it before stepping into the next step and saying, okay, we have solutions for the facade engineering. So Jason, can you tell us a bit more on how important is to set a baseline that covers the structural integrity, performance, code compliance, aesthetic when it comes to the facade engineering that we can rely on to say it correlates the existing or the current standards and codes, and it can also tally to the future vision of facade engineering?
Okay, I'll give it a go. I think there's two parts to the question. There's design and then construction. I think for design in the UAE, we've got a lot of guidance from Dubai Municipality, from ADM as well. But I think as coordinated multidisciplinary design teams, we shouldn't always just follow the baseline. We should be looking to work closely with mechanical engineers and with sustainability consultants to work out a more optimized design and actually what the best for the building is. And that's in terms of thermal performance, in terms of air tightness in particular. When it comes to structural integrity, the guidelines are set. Whether it's American codes or British standards or Australian or whatever, they're there for a reason. We need to follow them. I think generally we're pretty good at following in design, but I would say we fall down during construction. I think there's a problem with education of the people that are working in some contractors, and that's on us as consultants to advise during when we're advising during construction stages, but also on the contractors to properly educate the people that are working in design. And that doesn't just cover air tightness and thermal performance, but also movement accommodation, tolerances, acoustics. Facade touches on so many areas of a building project that we should really be across all of them. I think even then when it comes down to actually delivery on site, the baseline of what we design is very rarely actually achieved on site. And if we're looking to the future of engineering and the future of our buildings in 20, 30, 40 years, energy will get more scarce, and we need to design our buildings to be more efficient from the get-go. Buildings in the UAE, particularly down this road that are approaching 20 to 30 years old, are already severely inefficient compared to where they should be. And I think that's on us as consultants and as people leading contractors to ensure that all the people involved in the whole chain are understanding the reasons for doing what we're doing.
Thank you. Yeah, I mean, we always have to be mindful of the resilience of the cities that we're trying to build and the systems that we are installing later, how it will look like, into the maintenance process and what level of maintenance and accessibility to that we can achieve. Thank you. Serbi, moving forward with you, and we will be talking a bit more about sustainability and facades. So we are at a time where most of us is working on big projects in UAE or in Saudi, in GCC in general, and pushing boundaries in terms of architectural aesthetic and architectural design. My question to you is, how do you see that the role of facade is emerging into these high requirements for sustainability that are rising day after day and going more stringent day after day?
Right. So I'm just going to lead with what Jason just mentioned, that it is getting more challenging for facades to kind of juggle between the various functions, whether it's acoustics, whether it's structural, whether it's to do with the aesthetics or the human requirements for comfort and views. So it is getting quite challenging at the moment. And also add to that, when we're heading towards a climate crisis, we really need to look at designing facades for, changing weather patterns. There is a lot of change in the amount of elements or the elements that the facades are exposed to. So I would just, I would still go back to the simple principles when it comes to facade design, but we need to look at better materiality. We could look at nanotechnology as a way to kind of bridge, or juggle these various functions. We could also, look at kind of grounding these, having a more protective design, facade design. But then, the challenge then comes is how do you juggle that with the requirements for human thermal comfort? As we know, daylighting is essential in achieving a good circadian rhythm for human health. And it's really important, as well as the views that provide a connection to the outdoors. So, so there is this, sort of juggling act that has to be done. But for that reason, we can have like moving systems, better technology. But at the same time, we need to, go with the first principles. When we have like a client who comes to us with, say, a space that has a triple glazed facade, like triple height glazed facade, and then they have a really beautiful view to a western sunset. There is this, sort of juggling between, do we want to see the views of the sunset, or do we want to protect ourselves from the heat gain and the glare that comes from that facade? We need to kind of break down the facade into its, smaller chunks, where we see, okay, which part of it is going to, have accessibility to the views, and which part of it can be easily shaded. And then based on that, we kind of break the facade into different, parts of the facade, and then choose what kind of treatment do we want on which kind of facade. And some places we might use something traditional, whereas other parts we could use something like switch glass, which is a very modern technology that can, block the sun rays, or, when at a good time, it can just open up and become transparent again. So, yeah.
Great, thank you very much. Stuart, moving forward and still talking about sustainability, but also from an architectural point of view, Adjaye are very well known in their centric human design and interactive architectural articulation and geometry. Also, they are very well known by designing buildings that respond to the local environmental aspects as well. But how do you see the progress or the future of facade design with the requirements of complex geometry, more innovative material adapted into the architectural building design, is affecting the requirements for the material that can be circular or, more of a recycled adaptation of those material, and how is it responding to the strict global ESG requirements?
I think for me, this opens up a wider conversation about what we're doing on the architecture front. Internationally and regionally, we seem to be focusing a lot on investment making rather than placemaking. That happens both in communities as well as for the people living in apartments as well. Obviously, it was just mentioned, and you can see all over, especially Dubai, we build glass towers, which we do a VLT of, say, 40%. So it doesn't let in a great deal of light, but lets in a lot of heat. But people then have privacy issues. They put up curtains. They turn on their AC. So who is that really for? The question, the answer to that question is that views sell. But it's not really sort of applicable for the region and for people living here. I think learning lessons from that through history, that's sort of evident, especially in Abu Dhabi. 100 years ago, there were buildings like Qasr Al Hasan, which had no active MEP systems for cooling. So it was a facade-first approach. It was earthen architecture, which obviously was able to thermally regulate the space, and they had some passive ventilation. I'm aware that that is difficult to adapt to larger scales. But then you look through the 70s and 80s when they built the majority of downtown with the super blocks. Most of that was constructed with concrete and blockwork. Now, 40, 50 years later, the facades are covered in parasitic AC units because the insides are overheating. That then leads to people not desiring those buildings as much. The cost to maintain increases. The rent that the owner is able to achieve drops because of the desirability drops. And in terms of economic and, let's say, environmental sustainability, it simply falls off a cliff.
Yep.
I think we've not learned that lesson in terms of what we're building just now. We're building a lot of glass towers. We approach that in terms of solving the problem, or we seem to, let's say, be justifying that by talking about improving the glazing performance. But fundamentally, I think to be building glass towers in one of the hottest regions in the world is just fundamentally not a great idea. I think we should be building the glazing to a point where it is good for people's health, but no further. And I think in terms of, let's say, modular, in terms of it being modular or economically important, as time progresses, say in the next 40, 50 years, you look at buildings such as, let's use the Line as an example in Neom, predominantly or almost entirely a glass facade. And it was mentioned in one of the talks earlier that technology is changing so fast. If you look at, say, in another 40, 50 years' time, will the glazing spec be good performance, or will that even meet regulations in 40, 50 years' time? So what will they then do? Replace the entire building of glazing? I don't think that is a sustainable approach, even economically sustainable for a building. So I think fundamentally we need to understand what we're actually trying to create.
Thank you. Yeah, I believe we should encourage more and more the use of vernacular architecture and what material is available and adapted in the built environment, and that can actually respond to the heat that we are living in. Moving forward with Izzeddin, we will be talking a bit more about the link or the coordination that needs to always happen between facade engineering and MEP, two disciplines that we keep kind of fighting like with each other for requirements. But I just want to have your view on the importance of this coordination and what risks are associated with not coordinating, and what failures we can see later on site during operation and after handover of the building when those two disciplines are not well aligned.
Okay, again, thank you very much for your asking. I think somebody stop me if I exaggerate when I say the MEP are the most complicated systems in the building.
Correct.
And actually, architects always they wish us if we are not there and we are not exist in the building, so they implement their design as they wish. But now the importance of integrating the facade with the MEP, first of all, it is the efficiency of the energy. Then you will choose your glazing and insulation and whatever shading tools. Okay, that will also it will affect directly on the HVAC loads. And whenever you are using that one in smart way, you will have reduce the demand on the mechanical heat load, what do you call it, consumption. Less consumption means we are doing less energy. Less energy will go with less carbon footprint. So this is always something we need to take care of when we are designing the facade. Second one, it is the thermal comfort inside the area. Thermal comfort is very important when you are living in an apartment and you have, if this kind of facade is not giving you the comfort temperature from outside, then the AC, it will be like loading much on itself. So loading much means also consuming more power, consuming more energy. So this is something like before we are designing these systems, a proper orientation for the building, which will give you like a proper or reduce the, what do you call it, the heat gain from sun. Third one, which is like the natural ventilation. Natural ventilation and the air quality inside the apartment or inside the building itself. Again, MEP, if they are like well coordinated with the facade, they will give you a good example for where to open the window, or when you will open the window, or how you will open the window and how much. This will give you more quality air inside the area. And of course, there is one important thing that everybody knows that now in UAE here, we are asking for building certificates. For like sensitivity certificates, we're going with Dubai Green, building, Istidama, LEED, all of these, like they will demanding now you to do a proper coordination with MEP. Let's give you some examples, bad example and good examples if the facade itself is not well coordinated with MEP. This is from experience, I already done it with the construction. One of the bad experience we have that the vapor barrier and the insulation of the facade having an error in design. And that will cause us always inside the air apartment a condensation and moisture generation.
Correct.
This is something really critical. It cost the contractor a huge money to just to repair the walls and to get out from the fungus and mold happen inside the apartments. And it is not easy to get out from it. And small error in the design, it costs us a lot just to rectify that one. Bad example also, there are some areas we already under-designed the AC because the calculation from the facade, it shows something and the UV value is showing something else. So the under-designing the AC, it always will not give you the comfort temperature inside the apartment, will cause you like, it will cost you redesign and refixing a new system. One of the good examples we already fixed now in National Zayed Museum in Abu Dhabi, they having the automated ventilation facade. These facades, they have a kind of sensors which can read the temperature from outside and inside. When the climate outside it is cool or good, let's say, okay, they open automatically and they allow the cold air go inside the building, which will give less load on the HVAC system, which will operate less and will consume energy.
Yep.
And that one is very good example of integration MEP with the facade.
Yeah, I agree. I think everyone in this room can agree on the issue of the mold and the humidity that can happen because of a bad thermal line into the facade, a problem that consultants and contractors are seeing. Even us as consultants, we're asked to go on sites and inspect and check what's the problem, and yeah, bad insulation, bad weather tightness for the thermal line. Thank you very much. So Imran, we're going to talk with you about more the synergy between computational design and the BIM. So we're going to talk a bit more in here about the tools that we have and the adaptation of those tools into facade engineering and how we can take the step forward into the future of facade design using those tools. So my question to you is, what do you think, I mean, from your experience, what implementation of computational design integration with the BIM can be helping the optimization of the facade systems during the design stage and later on when it's handed to the contractor and manufacturing process?
Yeah, sure. I think firstly, just to add on some of the points my colleague mentioned, I think we all are mentioning about an integrated design approach. And when you want to bring that together, I think the technology plays a major role into that. There was a very interesting presentation before this panel speaking about AI and implementation, and that's where the industry is going. Obviously, it has its pros and cons, but it's either you get on the train or you miss the train, basically. So it's the same thing, like from our side, like we see how the architects and the other ones and the other disciplines are working. We're seeing the design of the buildings are becoming much more complex and integrated as well. Now, that could be simplified or enhanced by use of technology, computational design, and the tools associated to it, so that it's not only aesthetically pleasing, but is also looking at the energy efficiency side of things, the material aspect, which my colleagues mentioned, and the overall, the carbon impact associated to it. So I think some of the tools which we use, like in Ramboll, is the Rhino and the Grasshopper. We know the architects in the early design use Rhino a lot, and then we have found ways with the computational design team to integrate them into BIM. The advantage of doing that is allows you to look into the early analysis in the building when the architects are either defining the scope of the building. I'll give you an example. We are working on a building which has got a massive atrium, and the architects are speaking to us at an early stage that should that be an atrium, or should that be even a courtyard, or should that be a multiple courtyards associated to it, and how the facade could be integrated to allow maximum shading. Now, if you look into a traditional way, that could take you quite a long time to do it, but if you use tools like Rhino and Grasshopper and the dynamic modeling associated to it and integrate it into BIM and the early stage analysis, you can produce quite a few analyses which will be appreciated by the architects, but also appreciated by the client. And then, like it was mentioned in the previous presentation as well, you are doing a data-driven design. You are doing various iterations, and then you're giving a result out of it, and you're giving a data which can support the analysis associated to it. It can help you in terms of facade in establishing the right glazing ratios for the building, the correct shadings analysis as well, but also on the orientation aspect associated to it. So I think these are the kind of tools which we use. And when I speak of computational design and AI, there are a lot of progress happening in this. And for us, actually, we have embedded computational design into all departments, MEP, structure, facade, and everything, because we see a lot of value associated to it, especially at the early stage design, where client is looking at for a lot of options from your side, but they also need to be practical and catering to the sustainability requirements, the carbon requirements, and also the cost side of things. I will give you another example where we were working on a grand mosque project, and it has a massive facade associated to it and a very interesting Naqshti patterns aligned to it. But the cost for that was coming pretty high, and the client turned back and say, okay, we like the approach, but what can you do to minimize the cost? And I remember our facade and computational team worked together to look at the various iterations, and it was roughly around 50 to 60 iterations which were produced, and that was linked along with the cost side of each one of them to give the client an output in a week or two to make them the informed decision and produce a graphical content associated to it so that they can connect, they can see what result it gives on the facade side, the energy efficiency side, the aesthetic side, and also most important, which the client looks at, is the cost. So I would say Rhino, Grasshopper, and a lot of other tools which are there, which gets embedded into BIM, that's the way to go forward. And we see a lot of consultants are embracing that approach, and there are a lot of benefits associated to it. Yeah.
Thank you, Imran. We are seeing engineering consultancy implementing the computational design more and more as a specialty that supports other disciplines and that feeds into structure, facades, MEP, and other, even bridges and design, so they feed into the geometry finding and also the performance. Going back to you, Jason, and on the same topic, how do you think, what is the extent of the innovation that we can reach by adapting the AI-driven tools? And practically speaking, on the projects that we are working here in UAE or in Saudi, and the common typologies of the designs that we are dealing with, realistically speaking, are we really adapting those tools and the benefit, or time frames and rapid programs and low cost are kind of driving us to a certain point to skip this part and go with the baseline and go with the standard solutions that we know?
There's a few parts to that question. So I'll split it into, again, to design and construction. I think, like you said, generally a lot of consultants are using and exploiting what softwares such as Rhino and Grasshopper can do, and even Dynamo, and then writing in the APIs for Revit. But I think as a facade industry, I think we're still slightly behind on the full adoption of Revit and the benefits that can bring. In terms of integrating AI, again, I think we're slightly behind. I know the MEP industry, I've seen some great tools for simple things like duct rerouting or duct routing to coordinate with other ducts and other bits of construction. I think from what I've seen and what I understand, AI is great at achieving results if you can give it the right input. But although we're talking about language learning models and machine learning, I don't see that it's quite ready to take over from us on facade design. I think when it comes to existing buildings, there's got to be a great opportunity for the integration of AI for doing building surveys. We talked about the issues that we've all been involved with in buildings in the UAE, where there's facade issues coupled with HVAC issues that lead to huge amounts of air ingress and condensation and mold growth. One of the problems is, particularly down this road, that many of these buildings do not have BMUs. We've got aging facades, and we've really got no way of getting a trained eye up to take a look. So we're often reliant on Spider-Man to take pictures where they think they see an issue. I think the adoption of AI into our building surveys and maintenance and management of facades has got to be a real growth area. But going back to design, I'm eager to see what AI can do to kind of take out some of the opportunities for human error that we have in things like documentation. We're all starting to work in Revit, but I think we've all been through, everyone probably in this room has been through a process where there's been documentation error that has caused issues later on. I'm really interested to see how we can bring AI, as we go into the future, how we can bring AI in to de-risk and to remove errors from the work that we produce.
Thank you. Going back to you, Stuart, again, we will be talking with you a bit more on the compromisation that architecture is doing now for the human comfort, I would say, or the ethical considerations for the region that you are working with when it comes to designing an advanced technology reflecting a futuristic concept of a building envelope as the requirement or the approach of futuristic visions that we are seeing now, crazy geometry, crazy building material. How are we compromising in here, and to what extent architecture can still respect that there will be human beings actually living in there and interacting with those facades and those building envelope?
Don't do it. I think technology sometimes, especially in architecture, is quite a risky word. It's just been mentioned a few times. I think adopting technology to understand the building better is definitely a positive advancement. However, it was mentioned in one of the talks earlier that technology is progressing at an incredible pace. And architecture, to be quite frank, is quite a slow process. We really, if we're trying to really be sustainable, should be designing buildings to last 200 years. Sometimes we design buildings to last 50 years, and they will still stand after 200 years, but they won't be fit for that situation. I think you see, as an example, there was a little trend and hype for everyone going to buy Alexa and Google Home. And who has bought one in the past year? Nobody, hardly anyone. Mm-hmm. it progresses so quickly, and also a lot of that is sort of trend setting. If you implement some of that within a building or within architecture, you are partially at risk that the building could be standing for 5 years and already your technology is outdated. I think quite often what I hear is when you try to look for a solution that is good for the building itself, you'll hear, let's use an efficient HVAC system. Sure, of course, we need efficient HVAC systems, but in 10 years' time, that won't be efficient anymore. And it will cost let's say, the owner of the building to upgrade that. So I think we should be looking at, let's say, technology and innovative solutions that, I'll say, stem from history. And try to build projects that work as passively as possible, and the active solutions supplement it rather than act as a necessary requirement. For example, we recently completed a project in KSA, and below, it's a collection of buildings under a canopy, but below the surface we also have a thermal labyrinth. It's a completely passive thermal labyrinth, and it drops the temperature below the canopy by circa 5 degrees. That, even though that is a solution that's been implemented in this region for thousands of years, that is deemed, when I speak to people, is deemed modern and innovative because it's rarely done. I think we should be looking at ways of simplifying the buildings. They really should be, in my view, primitive, and any technology that you want to apply to it, that can adapt with the time, but it doesn't change the fundamental of the building itself.
Yeah, agreed. Going back to the fundamentals and the baselines is always key. Izzeddin, going back to you and to the synergy between facades and MEP, from your opinion, what fundamentals, again, or baseline strategies we should keep carrying on when looking into the future of facades?
Actually, exactly now, listen, MEP and facade, they are lit. I believe we need to consider them like as a one component. From the early stage of the design, we need to put an MEP engineer, facade engineer, sensibility consultant, and architect all together just to an early stage of the concept design, so they come out with a best solution that it will give you the best design out of faults. So this one always will give you the best part and less error in the future. Now, let's talk about AI in part of facade. The AI part of the facade, like why we are not using the sensors integration inside the facade. Sensor integration is something important which is not usually used now. But now, as a developer, we are insisting to having these kind of things in a new design. Because let's talk about like what is the part of the sensor when you open your balcony door wide, okay? This sensor, it will give a trigger to your HVAC system, like if the door keeps open for more than 10 minutes, the system will shut down. The shutting down of that system, first of all, will save for you money. It will save from you just in case of condensation, less humidity inside the apartment. It will save from you that the lifespan of your material will be better. And second thing we need to discuss is how you choose the material of the facade. Choosing the material of the facade, always they have to be in consideration that the heat transfer, always it should be something included in that system. For example, if you use kind of smart glass with low E, the smart glass with low E it has this microscope coating. This microscope coating will not allow the heat transfer between outside to inside, but it will allow you to have the proper daylight. Mm-hmm. So this kind of facade, always it have the best solution for MEP and facade. But unfortunately, like in this time, like we want to have the shape, we want to have what do you call it? The design, it need to be much beautiful. We need to have it more cheaper. These things, I believe, we need to put it in point now in early stage that when you consider MEP always, that it has the smart integration with the facade always will give you a best solution in the future.
Yeah, agreed. Surbi, talking about the material and the selection of the facade material, the facade systems usually have a lot of components from glass, aluminium, if it's aluminium, the other components, if it's a cladding, what would be the cladding material? What are we doing in terms of sustainability requirement to encourage more and more using the local vernacular architecture as implementing it as like a requirement rather than an option to the designers and the consultant, even for the operators, to encourage reusing the material that is locally available and stop importing the systems from abroad and adapting it in an environment and a region maybe that is not a home for it. How are we inducing this one into sustainability strategies nowadays?
So when it comes to glazing, as an example, when we have to specify glazing for a building, we have to give them like the VLT, the SHGC, and there is, again, it's a balancing act between the solar heat gain coefficient and the transparency of the glass that dictates its VLT. So this is a balance between the energy and the daylighting within the space. It is very challenging to find this glass locally, and usually it is imported, where it is able to provide you a better transparency and better heat protection at the same time. We need to use, some opaque facade systems that might be beneficial or that might have been used in vernacular architecture to kind of work with these problems. These days, we can, provide you insights on which orientation of the building requires how much amount of window-to-wall ratio, even before we've reached the, schematic design stage. So we can tell you that, your south facade needs a certain kind of shading, the east and west need a different kind of shading, and the north may not need shading at all. So we can give you these insights based on multi-attribute optimization studies that we carry out at a very early design stage. But again, this, we need to be approaching this as early in the design as possible. Also, when it comes to, vernacular architecture, they have, created fantastic mechanisms of, only selecting the desirable elements, outdoor elements, such as, cool winds coming in through the wind catchers to, improve the thermal comfort. So we need to, but the thing is that, a lot of these buildings, they don't really have the proper amount of daylighting, and they don't have like modern sort of psychological amenities for their occupants. So again, we need to balance the two. We need to bring in some modern elements, or rather have some, traditional elements in modern buildings to supplement the areas where modern buildings are lacking. Like, for example, in a wind catcher, it is able to kind of catch winds in the prevailing direction and, blow them into the building. But at the same time, they're not always effective during certain times of the year. And we need to have data before we come to, talking about AI and stuff. We need to have specific data, telling us what is exactly happening. And we have like modern sensors available these days. We have pressure sensors, we have relative humidity sensors to understand what is happening, what is the relative humidity above, on the top of the wind catcher, and what is it below. So we need to come at it with data, with real world data, and not only simulations data. And we can obviously, supplement it with a fan, like a solar powered fan, or a downdraft fan that is able to kind of bring in air at the times when it is not, naturally present. Yep. So we need to kind of work the two together.
Yeah. Thank you very much. Imran, going back to you, and from your experience with Najdi architecture, I would say, which is partially or like considered as one of the vernacular architectural construction design now we're facing. What was the challenges that faced you implementing the new methods in construction and design from an MEP perspective into a building that is implying to have a more of a vernacular material shell? Was it facilitating the process of your design, or did it have any complications during the design stage?
I would say, like, again, it's important to have that integrated design approach. I mean, there was a very interesting point mentioned by my colleagues over here. We recently launched the embodied carbon guidelines for MEP, and we actually, when we did the analysis of it and combining it with the operational carbon side, facade plays a major factor to it. So it's important that that aspect is looked at an early stage if you are talking about reducing your carbon footprint, especially the embodied carbon as well.
Yep.
And there's always a synergy and balance, like you want the best class that might not be locally available, and that could have the best impact on your MEP systems. But that trade-off needs to be studied at an early stage with architects, sustainability, and MEP engineers on the table from day one. I think Nashdi architecture, I would say, is like, from my experience working in Saudi Arabia, it's been quite good, because we have worked on the facades, which has provided us the shading side of things as well. But I think the other factor which I would like to bring in is, speaking on my previous question, is the integration of the different tools like CFD and also the energy modeling and everything. Like, I'll give an example of a high-rise tower. If it's 100-meter tall and above, you need a wind analysis associated to it. And that's required for facade, and that's required for structures, and we need to understand the data to inform our HVAC system as well. Now, if you look into all of that in an isolated way, then it results in insufficient design decisions. So it'd be Nashdi architecture or any other buildings you want to look at. So it's important that when the different teams are working on a particular project, on a particular solution, they use the technology in the right way, and they're using the solutions to inform the best design associated to it. Like, for example, my colleague mentioned about the issues on site, which we see a lot, where we get called in saying there's a mold and condensation issue in the building, your MEP system is not working. But often when we go in, when we inspect what's happening over there, we realize it's more a facade performance issue than an MEP system issue. Obviously, when you have leakages in your facade, that will react because of the system going below the dew point temperature, and the air conditioning is completely on, or even if air conditioning is off, you have the fresh air continuously on. So those sort of interrelations is really important to be considered in the early stage design, and use of tools like dynamic energy modeling, as well as the CFD, or using the thermal bridge analysis if you have a complex system, really helps. But it's also, we need to be mindful, and I agree with Stuart on that, is there needs to be a technical know-how to understand that data as well. Yes, we are progressing quite quickly, and especially for MEP, I'm a big fan of technology associated to it, because, like my colleague mentioned, it's a very complex system. So the more automation we bring in, is better for us and is better for the rest of the team. But also the technical know-how associated to that, to understand those systems, what is the output is generating, is really important. And especially like for our younger engineers which are coming in, they're growing in the world of AI, and they will be really dependent on those technologies. So it's a very fine balance in that regard. So I would say like Nashdi architecture is good from the MEP perspective, because we've done in the right way, and the right shadings and the materials, it helps us to save energy, but it needs to be looked at combining the technology side of it and an integrated solution with different disciplines on it.
Thank you, Imran. Jason, I'll close the session with you. If we are to sit on a round table today, facade consultants, operators, MEP consultants, sustainability consultants, and for sure architects, and we want to set the steps towards the future of facades, in your opinion, what would be our very first step to start with?
So there's two bits. I think something that the UAE is pretty new to is what to do with existing assets. And then we've also talked about new buildings. So Stuart, you were saying about building in glass. No IGU is going to last forever. Expect an IGU to maybe have a lifespan of 25 years, 30 years max. We don't monitor the performance of the double glazed units, and that then impacts on the HVAC system. So the future of facade, I think, will involve a lot of refurbishment. To be sustainable long term as well, we should not be building more if we don't need to. The most sustainable thing to do is to not build. I think then going forward with new builds that of course we will need. The population is ever expanding in Dubai and in the UAE. I think we really do need to take heed of some of the things that have been said today, and that is that design teams should truly be integrated from the get-go. We should deliver building designs that are responsive to the environment rather than just building big glass boxes that then suffer in the future. And we should be making sure that the people that build it understand what they're doing and why, and that we are actually designing for the design life in the specification or the building life in the specification and not just till the end of the DLP.
Cool. Thank you very much. Thank you for your attendance, for the panel. Thank you for the audience.
Ladies and gentlemen, please, huge round of applause for this panel. Thank you very much indeed. Thank you. Thank you so much. Thank you.